So can you guys tell me if my screen is visible to you? I'm sharing my screen right now.
I can see your screen.
It'll come anytime soon. Hey Pranav.
Hello, sir.
Look. So everybody is keeping their videos off today, okay? Because I'm doing it remote. Okay? Yeah. I hope you should be able to see my screen now. A whiteboard?
Yeah, we can see your screen, sir.
Wonderful. So what is that we are going to learn today? We are going to learn two things. One is called rational number addition and subtraction, and then we'll talk about negative numbers, the interpretation and multiplication and division of these numbers. And this is essentially part of grade 7, unit 4. But these are like, for me, these are like operations that we all should know, regardless of which grade we are in. Okay. So let's first look at what is our understanding of the different types of numbers, and then we'll talk about the operations with them, and then I'll keep on asking questions to you guys so that you know I mean how to stay engaged. Okay. Now, if I'm talking about the number line 0, 1, 2, 3, 4, everybody knows what is number line, correct? So on so forth. If I'm looking at only these number 1, 2, 3, 4, and everything in the positive direction, what are these called?
Positive numbers.
Natural numbers. Positive numbers and natural numbers. Yeah, natural numbers. Okay. If you include zero also, this set becomes whole number, meaning zero plus natural numbers. Natural numbers, when I say I'm going from 1 all the way till infinity, all in positive direction. Like you said, positive number, right? So all positive numbers plus zero together is called whole number. So that's the smallest difference. Now, if you include minus also, meaning whole number plus negative numbers, that becomes integers. Only this much is called natural number. Include zero, this becomes whole number. Include negative numbers, that becomes integer. So integers is nothing but the superset of all the numbers. Integers means all the numbers without any fraction or decimal, be it positive, negative, including zero, is called integers. Yeah. So this is with the numbers where you are dealing with numbers which is a complete number by itself. It doesn't have any fraction or decimal. This part is clear, right? What is a rational number? And see, for everybody in this class, okay, there is nothing, there is no problem with being wrong. Okay, if you make mistakes, I enjoy that. Okay, I want my kids to make mistakes, because when you make mistakes, that gives me an opportunity to teach you guys something. Okay, so just feel comfortable. Okay, if you even if you make mistakes, it's okay. Don't stop yourself from giving answer. What is a rational number? Now tell me. Let's see who all is making mistake.
Rational numbers are numbers
Mm-hmm.
that are fractions.
Yes. So I'll just give a little bit of background to that. Okay. So when we say rational numbers, see, one thing is fraction. We already had a term called fractions, correct? Why did we have to introduce another term called rational numbers? So let's say if I'm talking about 1 by 2, 1 by 8, 2 by 9, 16 by 5, these are all fractions, correct? So we know these are fractions. Why did we have to introduce another term unnecessarily to bother ourselves saying rational number? So to simplify that, fractions are mostly, when you refer to fraction, these are all the positive fractions, okay? Meaning this doesn't have any negative thing to it, okay? Only the positive numbers that you're dealing with, they are called fractions. But if you have something like this, this is a negative fraction with a negative to it, or fraction with negative value. So all that, like we said, okay, whole number, natural number, and then integers. Integers had positive and negative both. Whole number had only positive or zero and zero. Same way, fraction has all positives, and when you say rational numbers, includes everything, all types of fraction, be it positive value, negative value. So that's why people use rational number and fractions interchangeably. Okay. So are you guys with me?
Yes, sir.
Okay. So if I'm speaking fast, just stop me, okay? Like I keep on giving you guys the opportunity to make mistakes. I also have the same luxury. If I'm making mistakes, you can always stop me and say, sir, you're going a little too fast. Can you slow down a bit? Okay. So in summary, fractions are numbers which are not whole numbers or integers. Whenever you have a partial value to it, this is not a number which can be 1 2 3 4 5 6. It has a partial value, meaning something is divided partially among this many people. Let's say 2 by 4. What does it mean? Two things are divided in among four people equally. 1 by 3. One thing is divided equally among three people. So nobody is getting a complete thing. Let's say if you're talking about a sweet, Indian sweet, okay, let's say gulab jamun. So if there's one gulab jamun distributed among three kids, everybody gets a smaller portion. Nobody gets the whole gulab jamun. So whenever there's a partial thing to it, that is when it's called fraction. A fraction of something, a part of something, a small portion of something, right? So fractions, when you look at fractions plus fractions with negative values, altogether it's called rational number. That's where we will stop. Everybody with me so far?
Yes, sir.
Yes,
Okay.
sir. Yes.
Okay. So if so hereafter, whether you say it fractions or you say rational number, both are the same. Just that in absolute terms, when you say rational number, includes different varieties of fractions, meaning positive, negative, both. When you just say fraction, people would not assume that to have a negative value. Okay. So now, uh, do you guys? So we'll talk about in. I mentioned that we'll talk about what are the topics that we are going to cover. I mentioned that we will talk about rational numbers, addition and subtraction, and then negative numbers, multiplication and division. So let's look at rational number addition and subtraction. I know this is something very easy. You would not want to talk about that also. Let's see if I say 3 by 8 plus 2 by 9. Who all in the class doesn't know about this? And it's okay not to know. That's fine. I'm just first trying to figure out if you guys know about it. Everybody knows about it. Everybody is comfortable.
Yeah.
Everybody is comfortable. And I know nobody would want to stand out and say, okay, I'm the only person who doesn't know about it. Yeah. But I will be brave and say, okay, I don't know how to do it. Okay. If I have if I have to do it, I'm getting old, I'm forgetting things. So let me do it one more time so that everybody is on the same page. Okay. Now, the basic method that I follow for this is what? I will look at okay, this is a fraction. This is not a partial number. This is not written in decimal form. It is not written in as a mixed number. It's a simple fraction that I have to add. So this one is a fraction or rational number. This one is a fraction or rational number. Okay, wonderful. Everything looks okay. What I'll do is first look at the denominators. This has 8, this has 9. So I look at both the denominators, find out the LCM for this. LCM is in lowest common multiplier. And there's nothing common here. So I will say, okay, fine. 8 ones are 8. And then I have a 9. Then 9, 1 remains 1. 9 ones are 9. My LCM is 8 into 9, 72. I got my LCM. Wonderful. All that I'm doing is for you guys to recall and to be bored with this whole calculation, okay? So that next time when you do it, it's easy. Now I got LCM as 72. So I look at the first one. This is 3 by 8. What is my denominator? 8. How many times of 8 gets me 72? 9. 8 9 is 72. Okay. And then I will multiply that with what is my numerator here? 3. Fine. What is the sign next to it? Plus. I'm done with my first number, first fraction. Let's look at the second one. 2 by 9. What is my denominator? 9. How many times of 9 gets me 72? 8. Okay, let me put that in a bracket. 9 8 is 72. And then what is my numerator? 2. I'll multiply this. Now 9 3s are 27 plus 8 2s are 16. Divide by 72. It becomes 27 plus 16, 43. Divided by 72. This is my answer. Okay. Now, be it addition or subtraction, it does the same thing. Let's or the same approach. So let's say if it was not addition, it was subtraction. Everywhere I have a plus, I will replace that with a minus. And then I'll delete this guy. What I would have done in case of subtraction, same thing. First thing I did LCM for 8 and 9, I got 72. I put 72. Then 8 9 is 72 into 3, 9 to 3. Here plus became minus. It was a minus sign. So whatever is the sign, I'll use that here. Then it became 27 minus 16 by 72. So 27 minus 16 is 11 by 72. This is my answer. This is 11, not 4. So addition and subtraction of fractions is much easier. So I was just doing a recap so that if anybody is struggling to recall how did I do it, this is the answer for this. Okay. And even if you have a situation like this, says 3 by 9 plus 4 by 2 minus 8 by 1, 8 by 9. Even if you have to do it, approach remains the same. I will look at 3 fractions to be added. What I will do is first thing is find out the LCM. For LCM for 8, 2, and 9, all the denominators 9, 2, and 9. I'll get the okay. So here 9 is common. 9 1s are 9, 2 remains 2, 9 1s are 9. And then 2, 1, 2 1s are 2, 1. So my LCM is 18. And then I'll do the same thing. My LCM is 18. First one, 9 2 is 18, 2 into 3, 2 into 3, 2 into 3. Then I have a plus sign. I'll write a plus. Then 2 9 is 18. So 9, what is my numerator? 4. Okay. Then comes the third thing. Here it's a minus. I'll put a minus. And then 9 8 is what did I do? Okay, 9. Here is 9. 9 2 is here minus sign. 9 2 is 18. 2 into 8. This is my third one. So this is this plus this minus this by 8. And I'll do by calculation. So be it addition, subtraction, or addition, subtraction together, my approach doesn't change. I'll just do it simply. Everybody with me, right? I mean, this is just an attempt to make you guys recall. Nothing new. Now I'm getting into something new. So before I do that, I just want to check if everybody is on the same page. Yeah. Everybody with me so far?
Yeah.
Yes, sir.
Okay.
Yeah.
Now let's add some more fun to it. Okay. We don't study, we do fun with maths. Okay. That's the primary goal we have here. Okay. Now if you have to do this, who all knows how to do it and who all doesn't? And it's okay to say that I don't. That's fine. That's why we are here. We want to learn. Everybody knows how to solve this?
Yes, sir.
Okay, that's from Vivan. Okay. Um,
Yes, sir.
everybody, okay. Um, Gaushika, are you clear?
Yeah.
Sagarika,
Yeah.
Pranav, everybody?
Yeah.
Okay. V1 is also fine? Yeah. Okay. Now, so here, then, see, you guys are telling me not to teach you. Okay. You already know it. No, I'm just kidding. So here, this is a mixed number. This is a decimal, and this is a whole number. What will we do? I'm just doing it so that no everybody can relate. Okay, and see if whatever is my understanding is same as yours. This is a no, mixed number. This is a decimal, and this is a natural number. In scenario like this, our best friend is fraction. If I'm dealing with different number types, our first approach has to be to convert everything into one form. And apparently fraction is that one form that helps. Okay, so this is a mixed number, I'll convert this into fraction. This is a decimal number, I'll convert that into fraction. And this is a whole number or natural number, I'll convert that also into fraction. Now comes the next question for you guys. Do you know how to convert this guy, first one in this mixed number is into a fraction? What will the value of this in fraction? Can somebody tell me?
30, sir.
30.
30 over 8.
30 over 8. Yeah. So this is like a clockwise reaction. 8 3s are 24 plus 6, 30 divided by 8. Okay. This is a complete clock that we're dealing with. Yeah. So you go from here to here, multiply these two, then add these two, and then just write whatever you have in the denominator. So 8 3s are 24. This is into, this is plus, and this is the division part. So 8 3s are 24 plus 6, 30 by 8. So this part you guys know. So this is, I'm converting everything into one form so that no, we don't end up dealing with apples and oranges separately. We have only apples or only oranges. Okay. So this became 30 over 8. This part is fine. What about this second guy? 1.2. If I have to write that in fraction, what will that be? Anybody?
1 over 2.
1 over 2?
I mean, 1
It's
and
by 5. 6 over 5.
Okay. 6 over 5 is an answer. That is also correct. But I
12
will,
over
I'm sorry, 12 over 10. Yeah, that's also the answer. Yes. So I have probably taught this to most of you, but I'll just repeat myself. Whenever I have to convert a decimal into a fraction, first thing I'll do is I will write the number without bothering about the decimal. Okay. I will write it as is 1, 2, 1 and 2. I will write it. Now I have to take care of the decimals. So there's one decimal. So I'll write a 1. And then I will count how many zeros I have, how many digits I have after the decimal, this way, in the right direction. I have here one digit, so I'll put 10. Imagine if it was 1.20. I would have written 120 first, then would have written 1 for the decimal, and then two digits. So two zeros. That would have been my this thing. Okay. So simple approach. When I have a decimal, I have to convert that to a fraction. This is how we'll do. If I have this value, I'll put both the numbers without worrying about the decimal, and then a number 1 for the decimal and count how many digits I have. I have one digit, so I'll put this. So this is my second fraction. How about this guy? This is a whole number. I don't want to deal with different types of numbers. I'm trying to convert everything into fraction. How will I do it?
4 by 1.
Wonderful. See, I want to get to a state where you guys tell me that, okay, I don't need you, sir. We know maths enough. And that'll come with all the learning we do. So yeah, Now everything is like a fraction. It's very easy. Now you guys know that okay, I will find out the LCM, then deal with everything, then it'll be like okay, 8 and 10. 8 and 10 becomes what? 40 will be my LCM, okay? You will tell me how. This is how it will be. 2 is common, 2 4 ja 8, 2 5 ja 10. Now 4 1 ja 4, 5. 5 1 ja 5. So 2 4 ja 8, 5 ja 40. 40 is my LCM. And then I'll do 8. How many times of 8 is 40? 50? It's 8 5 ja. So 5 into 30 minus 10 times 4 is 40. So 4 into 12 plus 4, 40 into 4. And then we just go on doing it. 5 times 30 minus 4 times 12, whatever it is, right? So there's nothing new that you guys have learned. What only thing that we are learning is that when we do any operation with different types of numbers in that, we convert them all into one type. So if I have mixed numbers, if I have decimals, if I have whole numbers, I'll convert everything into fraction. Fraction is my best bet because everything can be converted to fraction. Can I convert 4 into a fraction? Yes, I can say 4 by 1. Can I convert every fraction into whole number? Probably not. 3 by 8 is one fraction. Even regardless of how much time I spend, I can never convert into a whole number. It'll remain a fraction. Yeah. So that's why fraction is the best friend with everybody. Fraction is like a common friend for all different types of numbers. You can convert everything into a fraction. So that's why when you have different number types to deal with, you convert them all into a fraction. And then once you have everything converted into one type, then you know how to play with it. Any questions so far?
No, sir.
No.
Oh. Now comes the interesting part of positive and negative. So let's say you have to deal with 50 and somebody says add these two numbers 50 and minus 10. So add these two numbers 50 plus you add these two numbers. So this is one number, this is another number. Add them. What will be the answer here? There
40.
is 40.
40.
Okay, yeah. So these are the operation side of it, which is again very important that we have to be careful about. Let's say somebody says 50, add these two numbers 50 and minus 10. People will probably end up ignoring the minus sign and say, oh, add 50 and minus 10. Okay, 50 plus 10, 60. You have to always do that in a layman's way, like I always do. I never pretend to be a very smart guy. I'm anyways not very smart. And it's okay. I've been told to add 50 and minus 10. Minus 10 looks very unique. Let me put it inside the bracket. Okay. Now, when I have this scenario, I'll say, okay, fine. I have 50 plus. Now I'm trying to break the bracket because something is inside the bracket. How do I deal with it? It's like a friend who has closed the door. Let me open the door and then talk to him or her. Yeah. So this is the door, right? This is the door between the two friends. We are trying to make this friend and this friend talk. There's a door in between. Let's break the door. How do I break it? Whenever you have a bracket, it is nothing but a multiplication sign, meaning you have to multiply this and this to break this door. So plus into minus. Now, now the thing comes about the multiplication of signs. Multiplication of signs. We know that if we multiply 5 by 2, it becomes 10. Multiply 16 by 5, that becomes 80. That we know. What happens when you multiply plus with minus, or minus with plus, or minus with minus? Simple answer.
Negative.
Yes. Simple answer to that is there is one way. If both the signs are same, multiplication of that is plus. Otherwise, it's negative. If both the signs are same, the multiplication of that is positive. Otherwise, it's negative. Now let's apply that. If both the signs are same, then the answer is positive. Here it's plus minus, not same, negative. If both the signs are same, answer is positive. If both the signs are same, the answer is positive. Otherwise, it's negative. So if somebody says minus into plus, if both the signs are same, then only it is positive. For these two, it is positive. Otherwise, negative. Yeah. So you don't have to remember plus into plus plus, plus into minus minus, minus into plus minus, minus into minus plus. No. It's a one line thing. If both the signs are same, positive. Otherwise, go wherever you want to go. It's negative. Yeah. So that is what we'll remember. Now you look at this. Oops. What did I do? Okay. Okay. Yeah. So, so here, uh, so we were talking about adding adding 50 and minus 10. Now we come back to this 50. We are trying to break the wall so that the friends can talk. Plus into minus. Both the signs are different. Answer is negative. And then the number comes as is. 50 minus 10 is 40. Got it. That's fine. Similarly, if you are talking about somebody says multiply 60 with minus 10. Same thing here. If somebody says multiply 60 with minus 10, if you don't have a sign anywhere, you can assume it to be a plus. So it's like this 60 into minus 10. Same thing. I'm just using that multiplication of signs thing in different scenarios. Okay. Now here, if you have nothing, you can say this is positive. Now here, you can multiply number with number 60 into 10. We are trying to break the brackets. So 60 into 10. This is one thing. And then second thing is we are trying to multiply the signs plus into minus into minus. So plus into minus, both the signs are different. It is minus. And then you multiply the numbers. So this is a simple part of it. So it was like dealing with integers. See, if you look at the syllabus, you will see that it says integers, addition, and subtraction. And then we looked at simple addition and subtraction. I would not want to bother you guys. That is something that you guys already know. But then how do we deal with different operations when you have signs around it, when you have negative value around it? How do use the signs to get the right calculation? So that was the part. Now, can we extend the same thing for doing fractions or rational numbers? Let's look at it. So if you have, let's say, 2 by 8 to be addition subtraction we did. If you have to multiply that with minus 1 by 9, what will happen? Simple, same way. Be it any rational number, be it integers, doesn't matter. Both are operations are pretty much the same. If you have nothing, you will say it is a positive. So you multiply these two, the number part, and then you multiply the sign part. Okay. So it becomes 2 by 8 multiplied by 1 by 9, and then you have plus multiplied by minus. So this becomes plus into minus is minus because signs are different, and then you multiply these two and get the value. So it's minus 2 by 8 9 is 72. Okay. Or 1 by 36, whatever it is. Up to this part, are you guys clear or any doubt?
Clear, sir.
So most okay, so most of the things that we are learning here, there is no brainer here. Okay, these are the things that is already known to you guys, and this one I'm picking up from Khan Academy itself, so that you find this relevant to you. And After the class, once I upload the video, what I will do is I will also send you guys the link for Khan Academy for these topics. You and I would request you guys to go and do the unit test for these and send me a screenshot of the test that you have done in Khan Academy. So that way it becomes, no, you guys will be able to see what we have learned, and am I able to do the standard question that comes for those topics. And if there's something that you're not able to do, that is what is an opportunity for me to you let me know that okay, this question I could not do based on whatever we had learned in the class. I'm still confused, and we'll pick up in the next class and try explaining that to you guys. Will that be okay? So I mean, in our class, for the new kids, in our class we do the class, and then after the class I give assignments the next day or the following day, and then I expect the kids to do the assignment and then show it to their parents. Say, okay, these are the sums that I was given, and this is how I'm doing it. So when they try explaining that to their parents, parents will know that okay, yes, my child has understood things, or you also will get a confidence that yes, whatever I learned, I'm able to explain that to somebody else. Okay, so that's what we'll do. So this time onwards, what I'm trying to do is try to give you guys the assignment straight from the Khan Academy itself so that you get to deal with the standard questions to assess whether whatever we have learned is matching with with what we are supposed to know or what we are supposed to solve or not. Okay, that'll be our plan. Now, one last thing before we disperse. I mean, today's class, as I said, this is a shorter class because I have to run for the airport right after the class. One quick thing that I would want you to know, we looked at fraction, addition, subtraction, converting different formats into fraction form, and then doing the operations. And we did simple multiplication with fractions also, including the signs. Now, let's say if you have to do division. Everybody knows how to do it?
Yeah.
I'm sorry?
Yes, sir.
Okay, everybody knows it. And do you guys know this is not math, this is dance? I think some of you know who has attended
Yeah.
it before. So whenever you do fraction division, right? This is not math. This is dance. Meaning you cannot do division just like that. You have to convert that to multiplication. This division sign, I'll convert that to multiplication. And when you convert from division to multiplication, somebody gets upset and starts dancing. And that dance is like this. The number flips. So when you convert this into multiplication, it becomes 9 by 4. This dance happened. So, and then everything is same as this one. So let's say if you have 3 by 7 divided by 9 by 21. Okay. So what will happen is you have to convert that into multiplication. Division is not easy, not fun. So you convert the multiplication division to multiplication, and then that triggers a dance. This guy goes up, this guy comes down. So this makes the number flip. It becomes this. And then it's like simple multiplication, right? You can do tic-tac-toe, you can break it down and do whatever you want to do. Yeah. So then the tic-tac-toe part, most of you know, we factorize this. 21, I can write this as 7 to 3. 7 remains 7. I cannot break it. It's a prime number. 9, I can write as 3 into 3. What we do is, in this kind of scenario, we break into smaller numbers and then we do tic-tac-toe. This 3 and this 3 gone. This 3 gone. This 7 gone. So basically, we have nothing but 1. Yeah. So you'll be surprised to know that even till 10th grade, 11th grade, when you guys prepare for SAT, math, all the things that we do in the junior grades, that is what helps to a great extent. More you play with numbers, multiplication, division, playing with mixed numbers, converting them to fraction, doing percentages and all. That is what builds your base for higher grades. So you have to literally enjoy doing all this. Okay, and that is what will make your base for higher grade, or for to make you guys do better in the city exams. So this is where we will stop. Any questions, any doubts, anything that we did not understand in the class today? I certainly want to hear from you guys, so that
No,
we can.
sir.
Yeah,
No, sir.
no doubt. Okay, wonderful. So let's disperse for now. I need to get going for the airport, and see you guys next Saturday. Yep. I'll upload the video in a bit, and then send out the assignment link for you guys to finish. Okay. All right.
Okay, sir.
Yeah. Yeah. Bye bye. Take care. Yeah.
No, sir.
Thank you, sir. Bye, sir.
Yeah. Bye bye.